Hello, everyone. We are Team Uber here at the conference. We're going to present our on-call copilot called Genie Journey and how we made it better. Myself here, Paarth, staff engineer in the Michelangelo ML platform team. Jonathan, Xandra, you want to give an intro?
Hi everyone, I'm Jonathan. I'm a software engineer here at Uber. While my time at Uber, I've worked on the data infrastructure team, the machine learning platform team, and now I'm doing various different machine learning applications for the data organization.
Hello everyone, my name is Xandra from Michelangelo, working with Paarth and Jonathan on Genie Oncall Copilot.
Thank you. So yeah, we'll like to give you guys some background why we built this, right? So this is how we kind of feel like on-call days and engineer days are in a company. You are really dealing with a multitude variety of tools, trying to debug issues, trying to get help, trying to move forward in whatever application you're trying to build, be it a ML application, Gen AI application, or anything else, right? Um, Now, generally, inside big companies, including Uber, there is a process to engage, get help from other on-calls, other engineers when people are stuck with a particular tool or a platform or a framework. But the problem is like people have to wait for other SMEs to jump in and get help. So there's a lot of loss of productivity, and it causes a bit of frustration on the engineers to need to wait for help. Another pattern we have seen is the information is scattered in many data sources. It could be Wiki, it could be Stack Overflow, Google Docs, Slack, and many other internal data sources. And it's very hard to figure out where the right information is located, and somebody has to search manually, which is again loss of time for an engineer to go away from the exact problem they're working on. So we also felt these pain points inside Uber, and we decided to solve it with Gen AI, and we built an on-call copilot. This was our previous architecture that we built with. We started with like a simple React agent, where we took some couple of data sources like Wiki and Stack Overflow. We ingested that with various chunking strategies that we found worked for them. We ingested that in a vector DB. Whenever a user asked a question, we would find relevant chunks from the vector DB, add that to the prompt, and call the LLM with additional tools to serve the user with whatever query they are asking. Now, this architecture worked okay in the beginning, but you know, there was a need to raise the bar on accuracy, which Jonathan is going to walk us through now.
Hi team. So I'm one of the teams I help support is our Query Builder platform team. So what Query Builder is internally at Uber, anytime you write SQL queries, whether that's querying data sources within our data lake or through MySQL, so MySQL tables, Hive tables, etc., you can always run them in this Query Builder, UI online platform. Some of the questions that we face on a day-to-day basis that don't really fit well into the Q&A platform that architecture that Parth just described are some that require more actions and interactions between like an on-call and the user. So for example, here's a question from a user that we get pretty frequently. I'm facing super high SLAs running queries today. Is anyone else facing this? Now, if you give this to a Q&A bot that the old Genie architecture worked with, the best it would do would be able to, scrape data from existing data sources and try and match the best one to in the embedding vector store to the question that was being asked. However, those types of answers would only be very generic. Rather, this user would need help right now fixing a current running issue that either the platform is experiencing or the user is experiencing. So it doesn't quite lend itself to the Q&A format that the previous architecture was built upon. Next slide. Here's another example. So a very common question we kind of get is, getting access to SQL reports. So in our system, you can publish reports for others to view, but these are all access controlled. So this is an example of an action. And what I mean by that is when the user asks a question, a bot needs to be able to take action. It needs to be able to look up what type of question this is, what sort of information is provided, and then be able to do a set of dynamic actions to fetch the appropriate information that then needs to be returned to the user. So for example, in this one, the user asked this question and the bot needs to be able to determine, okay, this is a category of questions where the user needs access to reports. Then it needs to be able to check various different things to see, is this report published? Is the owner still at the company? How do I access this report? Which, you own security group is this report published under in order to get access to this report? This is more of a dynamic thing that the previous architecture, which is more of just a Q&A bot, is not able to handle quite well. Next slide, please. So problems for the query builder platform that we just talked about. So kind of why are bots not that accurate? So many of these issues fall under things that a general on-call engineer would have to do if they get a question that is not just a knowledge-based question. So they might require some multi-pronged debugging. So many sources, excuse me, are required to be checked. That might be dashboards for, statistics about the health of the system, or, they might have to look at some of the logs. Many of these different hints and knowledge sources and data signals the on-call would need to check in order to formulate some sort of conclusion as to the problem that the user is experiencing. So this kind of lends itself to the second part. So many questions are not Q&As. So specific actions are required to take place. So the user, like I said, might request access to a report. So then what's the action that needs to be taken? Well, then the report needs to, first the user intent needs to be detected. Like, what is the user trying to do? And then based on that and the information provided by the user, various different API requests need to be called, need to be made to other services to gather, for example, metadata or other information in regards to what the user wants, and then formulate a coherent, actionable response to the user.
Yeah, thank you, Jonathan, for walking us through some of the problems we faced with the previous architecture. Just to even continue on further, with Michelangelo, also the ML platform at Uber, we had some similar flavor of issues that Jonathan was describing. Basically, like, for example, if I ask a question or post a code review that I need approval from an on-call, the bot would just answer saying, hey, I cannot do much here, because the bot had no access to the actual files in the diff. And it was this answer is not much helpful. The bot is not really assisting anything in this case. Another example where somebody's trying to do like a training run for their ML job, and the bot just says, hey, I don't have access to this link, and I figure out what's the problem in the link. I mean, that's a very obvious thing that the user would do before posting the question for help. So the previous architecture kind of didn't help much in this use case, because there are questions like this that were showing up. So what we kind of determined, our pain points were like, we needed more than just like the plain React style agent. We determined that there are certain category of questions that doesn't make sense the bot actually even handles, like code reviews. And then not all the answers bot was just giving, because of its restricted architecture, were actionable, which was causing, you can say, frustration in the users. User experience could be much better if we could enhance the architecture. So that's where we went from this React style architecture to multi-agent architecture. And I'll start with what we did for Michelangelo platform. So underneath, we actually added more data sources to improve the accuracy, because we found out there are different data sources have different strengths and different coverage of what kind of information they carry. So we added Slack and few other internal data sources that are not maybe listed in the diagram here. what we did underneath with the multi-agent architecture is when the user asks a question, we do intent detection first to figure out what is the user trying to do, because certain things like code reviews just don't even need to be answered by the bot. We just directly need to go to the on call. Other things which are non-code reviews, what we did is we have a question rephrase agent, which pretty much cleans up the question, rephrases it in a much friendly manner, which much compact and succinct manner. It passes it over to the hybrid knowledge agent. So now if you see on the left side, we have multiple data sources here. So we're able to leverage all of that using the hybrid knowledge agent, which can query all these various data sources parallelly to a knowledge agent, which has access to vector DB, tool calling, and prompts and everything, and be able to figure out which responses from which data source is actually much better, right? So there is already we are expanding the capability to be able to answer from many data sources and pick and choose which one we want to really answer, right? And then we, on top of it, we have an evaluation agent, because sometimes it happens that even if your data source has some information, it's not always the best one to answer. So we are evaluating the answer uh, before we give the answer back to the user, whether the answer is worth evaluating, whether it's good quality or not, right? So those were the things we kind of did as part of the multi-agent architecture to improve what kind of questions we cater to, how do we cater to, and all of that. Now Jonathan will walk us through what how we did the multi-agent architecture for data platform.
Yeah, so kind of building on what Parth just talked about and what we talked about previously about questions that aren't basic knowledge Q&A questions. So for Query Builder, what we did was we realized that there's a whole category of questions, and each category requires a certain unique, so to speak, flow in order to kind of address them in an appropriate way. So here for the architecture for Query Builder, we decided that this lends itself to a multi-agent approach. And what we did was we built our application based off of LangGraph. So LangGraph built on top of LangChain. So with LangGraph, we can have a graph topology where each node in the graph corresponds to a certain, action or part of the graph to resolve the user question. So going over the architecture for Query Builder just a little bit. The user question comes in from Slack and it gets sent to our service. And from there, we need to do some extraction. A lot of users, they're not going to necessarily paste their query or their, errors. They might just paste you a link to the query run that contains all the information you need, you may need. So in this instance, whenever a user question comes in, any sort of pre-processing occurs. So, SQL reports are posted, and then in that case, the queries are extracted using, a tool call, for example, API calls. The SQL errors are extracted if they exist, and from there, that extra additional context that the user did not directly provide, but indirectly provided through a link, will then be hydrated to the question that then gets further sent on. So moving on from there, then you have a couple other cases. So then, for example, if it's a Spark error and they're not really asking about, Presto queries, rather some sort of Spark issue, we need to be able to redirect to the Spark experts, so the Spark team that supports Spark. Otherwise, it hits, for example, our intent agent. Now, what does this do? So like we previously described, each type of question has a very different nature or flow. So therefore, the graph topology for each type of question will look vastly different. So this is where the intent agent comes into play. The intent agent needs to be able to classify the user question and what sort of question they are, asking appropriately. That way that it can feed into the appropriate subgraph to resolve their question. So from the previous slide, you saw a screenshot where a good number of our questions come in where users need access to, a report or some sort of table or column level access. Well, then the intent agent needs to detect that this is the type of question that, the user is asking. And then route it to the left side over here to the appropriate subgraph for that. And from there, various different API calls or tool calls are, initiated in order to fetch the appropriate information to let the user know which, LDAP security group, which security groups they need to join, who they need to, request permissions from. If the report is not published, they need to reach out to the report owner who is the report owner. We need to also be able to fetch and return that information to the user. Okay, so that's for, certain cases for, security types of questions. But then there are also non-security related or access related issues that then, the intent agent needs to classify that goes into a completely different subgraph. So here on the diagram, we have this whole fan out aspect to the right. And from there, one of the subgraphs of fan out is the hybrid knowledge agent that Paarth had previously described in the previous slide. So from there, the question is then, matched to the closest embeddings that, the hybrid knowledge agent has scraped from internal documentation, Slack data, and the closest K, matches are then returned and formulate, and using those are formulate an answer to the user question. We also send the question to other services, such as another internal one called Query Copilot, where if it's a query failure, it might try and help analyze the failure along with returning some sort of actionable fix for the user. Or if it's a data set search problem, for example, they're asking, what table do I need to query in order to find the number of trips in San Francisco in the last week? Query Copilot can do a data set search to try and find, appropriate tables based on the user question. These are all multiple sources, and then they're all returned down here in this final node called rank output, where based on the various different sources and the user question, we have the agent determine which answer is the best. And some of the criteria that we use for the best are more detailed answers are better than generic answers. Answers that are more actionable are ranked higher than those that are non-actionable. And then from there, the best answer is then returned and summarized to the user. So this is kind of like a larger graph. As you can see, it's a graph topology for various different types of questions that may come into the Query Builder channel. Next slide.
Evaluating how well a Copilot and service updates contribute to our user experiences is very important for product iterations. And not surprisingly, we ran into a couple of challenges that included few users provided thumbs up, thumbs down, and even verbatim feedback. And we were in need of an automatic evaluation system that could scale for growing support channels. If you're familiar with Slack, Slack messages usually contain multi-turns and messages from multiple users. For example, we needed to identify how well Genie assisted users and on-call engineers based on their conversations. Next slide, please. We next illustrate the evaluation architecture. From the top, we design prompt templates for ordering multiple Slack channels and use cases. The prompt engineering pipelines evaluate how well and how helpful Genie in this process based on a skilled metrics. 0, 1, 2, where 0 indicated the Genie was not very helpful in the process, and 2 indicated that Genie did a great job for resolving user questions based on the conversation between user, Genie, and also on-call engineers. The prompts also summarize the key points of each Slack thread for data source injection. We extract and also refresh such metrics and Slack summaries based on dynamic schedules and connect to Google Looker Studio for dashboard report visualization, and also connect to our backend Genie LangGraph agent pool. for data enrichment. And user feedback service serve as the data source for generating offline golden data set, which we utilize for evaluating how relevant Genie responses are corresponding to user questions and also extracting right context before Genie responses are delivered to users. Next slide, please. We started our Genie Copilot with the core functionalities built upon LLM services, email reactor database, and engineer wiki articles, then powered using various in-house and open source tools, and then multiple data sources, and finally scale to the multiple agents as in our current state. Next slide, please. We're happy to share some of our good learnings. User expectations have definitely risen from bots. Users expect that Genie Copilot can understand the multi-turn context and ideally taking the Oncall engineering knowledge as response sources. This happens especially when users ask common or frequent questions. And standalone RAG is no longer sufficient. The good news is that after we scale to multiple agents, we have observed much more impressive metrics and user feedback. Evaluation generally needs a lot of sophistication to get you right, and different Slack channels or teams have different needs, and typically they require customizations. Next slide, please. In the end, we want to share our future plans. We plan to use fine-tuned model in our evaluation process and gradually or continue to expand with different data sources. And we also hope to integrate with third-party apps to get additional context. And we hope to support faster knowledge refresh.